In this video, I'm going to show you how to estimate a limit numerically. But first, what is a limit? Well, informally, we can say that if the value of a function approaches a specific number as the x values get closer and closer to a specific number, then that value of the function that we are approaching would be the limit. So looking at this example, we have a function, and we want to find out what happens to the value of the function as x gets closer and closer to the number 1. If it turns out that as x gets closer and closer to the number 1, the value of this function approaches a specific number, that number will be the limit, and I'm going to show you how to estimate that. You will learn later that for simple polynomial functions, like f of x is equal to x squared plus 3x. If I wanted to find the limit of the function as x approaches the number 1, I could sort of cheat by just plugging the number 1 in for x, and that's going to turn out to be the limit. So it turns out that for a simple function like this, if I just evaluate the function at the x value that I'm interested in, that's going to be the limit. So this would be 1 plus 3, which would equal 4. So it would turn out that for a simple function like this, the limit as the x value gets closer and closer to 1 would be 4. Now, for more interesting functions, it's going to be a lot more complicated than that. So I purposefully picked a function and a value that we couldn't simply plug in, because I don't want you to get into a habit of thinking that that's the way to find the limit. What would happen if I substituted 1 in for x? Hopefully you can see that that's going to cause a problem here in the denominator where we have x minus 1. If I substituted 1 in there, then that's going to give me a value of 0, because I'm going to have 1 minus 1, and that's going to be 0, and you can't divide by 0. All right, that would be undefined. So what will we do instead? Let's use this table of values to explore what happens to the value of the function as the x values get closer and closer to the number 1. It's important that we look at values that are getting closer to 1 from the left, in other words, from below the number 1, and we need to look at what happens to the function as we approach the number 1 from above, from the right. Let's go ahead and type this function into our calculator to get us started. I'm going to hit the table function here, and let's just type this guy in. So we have x to the third power minus 1. So that's going to be x to the third power minus 1 over x minus 1. I'm going to go ahead and use the ask x feature, which will be perfect for what we're doing. All right, so let's type in 0.75 and see what we get. All right, they're giving me a fraction at first, but I want the decimal, and that is 2.313. I'm going to use 3 decimal places, so 2.313. All right, let's see what happens at 0.9. All right, now we have 2.71. All right, we're getting closer and closer to 1. What's happening to these y values? Let's try 0.99. All right, so that's 2.96 0.970. And how about 0.999? All right, so getting really, really close to the number 1. Okay, so that's giving us 2.997. Okay, so what we've done so far is we're approaching the value of 1 from the left. So just remember that wording. So far we've indicated what's happening as we approach 1 from the left. And it looks like the value of the function is getting closer and closer to 3. 2.997, that is really, really close to the number 3. But before we can declare that 3 is the limit, we need to look and see what happens to the value of the function as we approach 1 from the right. All right, so let's take a look at what happens at 1.25. Okay, that is 3.813. All right, let's try 1.1. That is 3.31. How about 1.01? And that is 3.030. And finally, as we're getting really, really close to the number 1 from the right, let's try 1.001. And that is 3.003. Because the value of the function approaches 3 as x gets closer and closer to 1 from the left and the right, then 3 is the limit of the function as x approaches 1. So here's the notation that we use. Now this would be read, the limit of f of x as x approaches 1 is 3. That's how you read this, and that's the situation that we have here. Let's take a look at the graph so we can just really understand what just happened. So here's a graphical look at what just happened. It turns out that there is a hole at the value of x equals 1. So, and of course that's because the function was undefined at 1, as we already knew. As the x values get closer and closer to 1 from the left, you can see that the y values are getting closer and closer to 3. And in the same way, as the x values are getting closer and closer to 1 from the right, the y values again are getting closer and closer to 3. Notice that it doesn't matter that the function is undefined at 1. The limit as x approaches 1 can still be 3, even if the function is not defined at 1 itself. That doesn't matter. Let's look at one more example. Let's estimate the limit of the function f of x shown here as x approaches 0. Notice again that we will get an undefined value if we try to simply substitute 0 in for x. If we put 0 in for x, focus on the denominator here. I will have 0 plus 1 minus 1. 0 plus 1 is just 1, so that would be the square root of 1 minus 1. And square root of 1 is just 1. And then 1 minus 1 is 0. And this is undefined. So we're not going to do that. Instead, let's look at a table of values. So this will be very similar to what we did before in the first example. Let's go ahead and type this function into our calculator so we can investigate. All right, so we have x in the numerator, and then we have the square root of x plus 1. Got to get out of there and put our minus 1. All right, I think I will just slide this over here so I can work from left to right. So let's start with negative 0.01. All right, I am getting 1.995. All right, how about negative 0.001? Now I'm getting 1.999. I am running out of space fast. In fact, I think I might need some more decimal places. Let's go ahead and let's do 5 decimal places. Let's go crazy. So this is 1.99950. If I go back and add in the extra decimal places for the first one, I get 1.99499. Let's take a look at negative 0.0001. No, it's too many zeros. Okay, so this is 1.99995. All right, so it seems pretty clear that as we approach 0 from the left, the value of the function seems to be getting closer and closer to 2. So I think I'll go ahead and write that down. F of x approaches 2. So let's see what happens as x approaches 0 from the right. Let's see what happens if we enter 0.01. Okay, so we get 2.00499. All right, how about 0.001? All right, so we got 2.00050. And finally, what happens if we use 0.0001? Oh, it's too many zeros. Okay, so we are getting 2.00005. So again, it seems clear that as x approaches 0 from the right, the value of the function is approaching 2. All right, so in that case, in terms of limits, we can say that the limit of f of x as x approaches 0 is 2. And we can use our limit notation and write it this way. All right, let's go ahead and take a quick look at the graph so we can get a better understanding of what we are dealing with. So here's what the graph of f of x looks like. But in terms of limits, as the x values were approaching 0 from the left, you can see that the y values were approaching 2. All right, in other words, the value of the function was approaching 2. And as the x values were approaching 0 from the right, again, the y values, or the value of the function, was approaching 2. So when the value of the function approaches a specific number from the left and from the right, then that is called a limit. And again, notice that it doesn't matter that the function is undefined right at 0. All that matters is what the function is approaching as you get closer and closer to 0. It can be undefined at 0, and that's perfectly fine. Notice that in both of these examples that we did in this video, we're just estimating the value of the limit. In future videos, I'm going to show you how to analytically determine the limit of a function precisely without having to estimate. But that's coming up later in the unit.